Okay, this is going to be a review video for the Algebra 2 SOL. This is the first video, okay? So what you do with this, since it's a square root, I got 2 and 10, 2 and 5, okay? That's prime. Cross that out. I can take 1 per circle group, all right? I have this left over. Then I got to take my exponent. The way you do this is exponent divided by root. So 16 divided by 2, which is square root, would be 8. So that's x to the 8th on the outside. 25 divided by 2 would be 12 and a half, okay, or 12.5. So that means y 12 on the outside, that exponent of 1 on the inside, okay? And so that would be that answer, answer C. All right, this one we would want to multiply those. That's 24. We want to add those exponents, which would be 12, and it's cube root. So 2 and 12, 2 and 6, 2 and 3. Cube root, I'm circling 3. I'm still only allowed to take 1 per circle group, so 2 cube root. All right, I got 3. Now I'm going to take 12 and divide it by 3 because that's the root. So that's going to be W4. So that 2W4 with 3 on the inside will be letter A. All right, which is the step between 4 and 5. Okay, all right. So like this would be like the inverse property there. Okay, what justifies the work between step 4 and step 5? Okay, you would have the identity property of multiplication. Okay, properties aren't as important, but identity means self. Okay, all right. What is equivalent? So what we got to think about is what does that line mean? It means division. All right. Now, what's the rules? Well, see if you can reduce this one. See how this one sort of looks like that? I would take out a -1 and make that. Division, I would do keep, change to multiplication, flip. So what would happen here is this would go away. That would be -5 W6 over 30 W2. If I divide that, I get -1/6. W6 minus 2 would be W4. All right, so that's -1/6 W4, which would be that. Okay, what is the factorization of this? All right, you would look for a GCF, which would be 6x. If I took that out, that would be 3x cubed plus 2x squared, okay, minus 1. Okay, all right, which that would probably be most likely be that, okay? All right, these other ones don't give us that possibility. What is equivalent to I-75? So what you have to understand is that I's work in increments. Now we have to use Desmos here. Okay, let's see. I don't think that you can do, I don't think it will figure out. No, it will not. So you have to understand that I to the first is I to the second is -1, I cubed is -I, and I to the fourth is 1. So you got to look at, well, what is 75? 75 divided by 4 is 18 3/4. Okay, so what that refers to is that's going to be I3, which means that's going to be -I. Okay, all right, which thing is factorable? So remember the idea of factor, 1 times, that's going to be -60. Okay, factors of -60. Okay, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that's it. And then you would keep that chart going, where it'd be 10 and 6, 12, 15, 20, 30, and 60. Okay, so the question is, which set would make that factorable, okay? Well, since one side is negative, okay, do any of those add up to 61? They do not. Do any of those add up to 23? They do not. Do any of those add up to -7? Okay, they do. This set. And so that's why that one's your answer. Okay, what's equivalent to this? Now, once again, here's what I would do. I would take out the -1 there, make that 4x squared minus 25. All right, I got 6x squared plus 9x minus 15 times 6x squared minus 2x minus 4, 2x squared minus x minus 10. So you have to factor all these. Now that top one's easy. That's just going to be 2x plus 5, 2x minus 5. Okay? What you should do with this one is that's got a GCF of 3, so that's going to be 2x squared plus 3x minus 5. Okay, so I have to factor that. I'm going to do that over here to the side. Okay, that would be -10. Factors of 10 that would add up to +3 would be +5 and -2. Okay, so that's 2x squared plus 5x minus 2x minus 5. That'd be 2x, that'd be x, that'd be -1, that'd be 5. So 2x plus 5, x minus 1. Okay, with this, I would take out a 2, which would make that 3x squared minus 1x minus 2. 3 times -2 would be -6. Factors of 6 that would add up to -1. That'd be -3 and 2. So I got 3x squared minus 3x plus 2x minus 2. That would just be x. That'd be 3x. X times this is 2. X times that's -1. So 3x plus 2, x minus 1. That doesn't have a GCF. So 2 times -10 is -20. The set that would add up to -1 would be -5 and 4. So 2x squared minus 5x plus 4x minus 10. That would be x. X times 2x. X times -5. 2x times 2. So 2x minus 5. X plus 2. Okay? So diagonally, you can eliminate like ones. Vertically, you can eliminate like ones diagonally. So what do I got up top? I got -2 up top. I got 3x plus 2. On the bottom, I have 3 and x plus 2. Okay, so that would be that one. Letter C. A lot of factoring in that. Okay, what's equivalent? Now, in order to add the fractions, I need a common denominator. So that's x minus 4, x minus 4. This is x plus 1, x plus 1. So that's 12x minus 48 plus 1x plus 1 all over x minus 4, x plus 1. If I combine the like terms, that's 12 plus, that would be 13. That minus that would be -47 all over x minus 4, x plus 1. That would be that right there. Okay? All right, another one of these ones, but now they want these kinds of things. So what I got to do is 36 to the 1/2, x to the 9 over 2, y to the 25 over 2. Okay, because there's like a 1 on the inside there. Okay, now if I do 36 to the 1/2, which that's 36, use this AB button, 1 divided by 2, that tells me 6. And this just stays 9 over 2, 25 over 2. And that would be your answer. Okay? Solving equations. First of all, you can't have something equal to 0 because if I put 0 in, that's no good. So I need a common denominator. That's 3 times 5 there. So that's going to be 15. So 15 times this. I would need a times 5 here. All right? So I'm going to multiply by 5 here. Here I need a times 3. Okay? So I got 15x plus 30. Plus 5x minus 30 equals 6x plus 27. Okay, if I combine like terms, that's going to be 20x. Okay, that's going to go away. I got 6x plus 27. Subtract 6x. That's 14x equals 27. Divide by 14. X equals 27 over 14. Okay? All right? You could always try these answers in to see which one would work for you. All right, how many values will satisfy this equation? Okay, all right. So if you go to solve this, divide by -2, divide by -2. Okay, normally what we do is we split this into two problems. One is that, and the other one is we put a negative in front of that, but that's just gonna be 0. So it ends up being the same thing. So 3x equals 5 divided by 3 is 5/3. Now we always got to check, if I were to put 5/3 into there, would that give me, would that work? It would. So only one value, one thing would solve that. Okay, these are graph match. What I would do anytime you have a graph is just put that graph into Desmos and just make sure that it matches. I wouldn't overly complicate this. This is where the inequalities are here, this little a, b thing, x plus 4. Close it, and I got a -1 on the outside. So I would just type those in just like I see it. Okay, I'm zoomed out really far. Okay, and so what I got is I got that thing that goes right below 4, and it's shaded in that way. Okay, so I look at that, that best answer would be letter B. All the ones that are graphing, I would just type those in. Okay, what's a solution for this? All right, subtract 5. All right, so I got 2 minus x is equal to 3. Okay, now the idea is, all right, this can't be a negative number. Okay, I square this, I square it. I got 7 minus 2x equals 9. Subtract 9. I got -2x equals 2. Divide by -2. I got x equals -1. If I put -1 back in there, that would be okay, because that would be 7 minus 2 times -1, which that's 7 plus 2, which is 9. Square root of 9 is 3. So that'd be my answer. Okay? What's the parent solution set? It's where it intersects. So I got a solution at -4, 3, and I got a solution at -1, 0. Okay, don't overcomplicate. Some of these are that easy. 16, which best represents this one. Now, it's a number line graph, so here's what I would do. I would go ahead and put these in. X minus 11, close it, greater than 4, okay? All right. So what you're looking for is shading between, that's like -11, and that's 4. So now, if you look at this, the shading's on the outside, so that can't be it. So let's tweak this a little bit. This next one, they want it to go this way. All right, so if I click there, okay, that obviously is not on the negative side. That's on the positive side, so it can't be this, these two, okay? And then this one would be here, 2x plus 7, close it, greater than 15. All right, that's shaded to the outside, so it can't be that one, okay? And so if you did put this other one in first, okay, why is that? Well, if I zoom in here, okay, I can see that this crosses at -11, and it's an open circle, okay? And then the other side is 4, and that's right there. So that's why that's the answer. Any of the graph ones, I would consider just typing those in. Okay. All right. What would make this true? So what I'd have to do is cube both sides. So it's 2x minus 5 equals 3 cubed. 3 to the third would be 27. Add 5. That's 32 equals 2x. Divide by 2. X equals 60. Okay. All right. That's the answer for that. You would just type that number in. Okay. What are the apparent roots of the graph? Well, the roots are right here, so they're fractions. So this can't be it. This can't be it. This can't be it. It's going to be this. Okay. Why? Because -3 divided by 2 is -1.5, and that's about where that one is. And 1 divided by 2 is 0.5, which is about where that one is. So don't remember the words solutions, roots, zeros, x-intercepts, they're all referring to the same thing. Where does it cross the x-axis? Okay? This one, your solution can't equal 0 because that would be an extraneous solution. What would I need here? I would need 2x, so I multiply by 2x. What would I need on this one? Just an x. So that's going to be 6x squared minus 8x equals 3x. So the way I would solve that is I would bring that back. Oh, whoops, this one doesn't need an x, I'm sorry. I would not need an x that first one. Let's back up here. Okay, this one would just need 2. All right, this just needs 2, sorry. This needs an x, okay, all right? So I get 6x minus 8 equals 3x. Okay, so that's, subtract your 3x. That's 3x minus 8 equals 0. 3x equals 8. Divide by 3, I get x equals 8/3. And that would be my solution right there. Okay? 20, what is the solution of this system of equations? If they give you the equations, you can always just type them in, especially to get down to systems. Okay? Plus x minus 8. Okay? All right? And then what I'm looking for is where does it cross each other? At -2, -6, and 5, 22. Okay? So that'd be letter D. So any of the equation graphing things, go ahead and put those in. Okay? Where does that intersect the x-axis? So what I would do, very simply, I would put x plus 1, and then the next one is x squared plus 8x plus 16. Okay, and they want to know where does it intersect the x-axis at? If I move around, this plus and minus sign will zoom you in, zoom you out. Okay, so it touches there and touches there. Okay, so it touches at -4 and -1. Okay, all right, and that's it. That's a double root on that one. Okay, where is this increasing interval? Okay, so what I would do on that, once again, if you're given access to this Desmos, use it. All right, as you notice, I didn't type in the f of x. You don't need that. Okay, so what I got for my graph is I got this shape where that is 1, -4. Okay, this would be -infinity, infinity. This would be positive, positive. Okay, so they want to know where is it decreasing. Well, remember, we only care about these values. It's decreasing from -infinity to 1. Okay, all right, so that's why that is that answer. Okay, all right, g of f of x. So this is the function you start with. You start with the g function, okay? So you do 4, all right, 4 minus 15, okay? Then I'm going to input this function, 2x plus 11, okay? All right, now what you would have to do with that, you could do a couple of options. You could do graph comparison. Okay, and what I mean by that is that would be 2x plus 11, okay, to the 4th power, okay, minus 15. This is one way to do it, okay? And what you'd be looking to do is you'd be looking to match this. Now, the problem is if you put the second one in, watch where this goes. Okay, that's not the same thing. Same thing if you do this. Okay, x to the 4th minus 4. It's not the same thing. Okay, all right, and then you do x to the 4th minus 19. That's not the same thing. This is the best example. But if you wanted to actually multiply that out, first you'd have to do this, which is 2x plus 11. Whoops, I'm sorry. 2x plus 11, 2x plus 11, that's 4x squared plus 22x plus 22x, okay, plus 121, Okay, so that's 4x squared plus 44x plus 121. And you'd have to multiply that by itself. Okay, cut them all up. Okay. I'm sorry, I started with the wrong function here. I started with the f function. Let me clear this off. Sorry. Wonder why that wasn't working. Sorry about that. I do start with the g function. That would be this. Apologize. And then I insert that function. I don't know why it was working that backwards. So actually it's not that hard. So I do combine these. That'd be minus 19. Sorry. I was wondering, I was like, man, they made you multiply all that. Apologize. Okay? A normally distributed set of data has a mean of 0, standard deviation of 0.5. What is the closest percentage to negative 1 to 1? Okay? So what you have to type in here, if you type normal dist, or norm dist, sorry. I think if you put the parentheses here, yep. So if you type normal dist, okay, all right, so type normal dist for distribution, okay, the thing will prompt you. Mean is the first number, so that is 0. The standard deviation is the second number, which is 0.5. And what I want to do is find the probability, so I select that. So between negative 1 and 1. 95.44. So if I wanted to multiply that by 100, that gives me this percentage. So normal dist, put your mean, put your standard deviation. Okay? All right? Okay, it says point A lies on this graph, which has negative 2, 1. Locate the image that point A lies on the inverse. So what you do with this is you switch your x and your y. So this would be 1, negative 2. So 1 over negative 2 down, and you would press that button there. Okay? Which equation best represents this? Once again, anytime they have these equations, I just would type these in. All right, 3, all right, 1 divided by 5. You click over, exponent x, okay? That's a pretty good one. We like that one. Well, let's see what the other ones look like. That's a pretty good one though. 3 square root of 5x. Yeah, that doesn't look right, okay? All right, 1 divided by 3, click over, and I think if you go functions and find log, by the way, normal dist thing is right here. You don't have to memorize that. Oh, here it is, log. Log 5x. Okay, obviously that's not a good one either, so this is bad, this is bad. Let's take a look at this 1/3, 5 to the x. 1 divided by 3, parentheses 5, to the x power, okay? That's going the wrong way. So that's going to be your best. Any of the graph matches, that's what you should do. Okay, I'm not going to mess this up this time. G, that's the function I start with. Then I'm going to insert this function. Okay? All right. Now, what they want us to do is put negative 1 in there. So I got to do every spot where there's an x, I'm going to put a parenthesis. Okay? And so that's how I would calculate it. If you want to calculate it out, you could. Okay, 2 parenthesis, an extra parenthesis, negative 1 squared. plus 3 parentheses negative 1. There it squared. Gives me 8. Okay, if you wanted to actually figure that out, okay, and then insert it, that works too. Okay, all right. Okay, let's go on to the next one. Question 28 says the volume varies jointly with height and the square of the radius. Okay, so direct variation is always y equals kx. Inverse variation is y equals k over x. Joint variation is usually a multivariable one. So everything, so sort of these are pretty similar. The inverse one pushes that underneath. So it says the volume of the cone, so that's the first one, varies jointly with the height and the square of the radius. Okay, so that would be the best example. And if I looked at the letters, that's what I would pick. Okay, what is the horizontal asymptote? Well, what we know is from an exponential, it's y equals, and then whatever that number is, gives us our asymptote. Okay, all right, as x approaches infinity, which best describes the said behavior? Okay, well, what I would do, they're giving you some generic ones. Why don't you just put in x to the 7th, and you can see that graph. So what would that be? That would be infinity, negative. This would be negative, positive. So what best describes the end behavior? As f of x approaches positive infinity, so as x approaches positive infinity, they're saying so x approaches infinity, y approaches negative. As x approaches negative infinity, y approaches positive. Now, f of x is a fancy symbol for y. So an end behavior for us is f of x approaches positive infinity. Oh, as x approaches negative infinity, which is this one, that would be positive infinity. I have to read a little bit. I sort of skipped ahead in the directions there. Okay? All right, so they're telling us this is an exponential relation. So what I have to do is I go into Desmos, I make a table. I put these numbers in. 0, 1, 2, 3, 4, 5. This is 23,000. This is 20,000. This is 16,000. This is 14,000. This is 12,000. And this is 10,000. Okay, all right. And so in the second line, I have to give the approximation. Since these all, I do y1, that accounts for that. I hit ABC, I select this little squiggly thing, okay? Then I'm gonna do, A, parentheses B, exponent to the x1, okay? All right, and if I scroll down, it tells me what the A would be. It would be 2300, 103, and the B would be 0.85. So which best one represents that? That would be that example, okay? So you have to know that anytime you have the x and y, but that's the standard equation. So for exponentials, it would be y1, okay, A, B, x1. For quadratic, it would be y1, ax1 squared plus bx1 plus c. For a cube, it's going to be y1, ax1 cubed plus bx1 squared plus cx1 plus d. And that's how you would type that in, okay? Depending on what the function is. Okay, what is the sum of this infinite series formula? Okay, so we give you on the formula sheet this. Okay, well we know A1 is 9. My R is the second divided by the first. So that's negative 6 divided by 9. If I do negative 6 divided by 9, and if I hit this little fraction symbol, that tells me negative 2/3. So I got 1 minus negative 2/3 for the rate. Okay, so 9 divided by 1 minus negative 2 divided by 3, double, whoops, hit over, close that parentheses, close that one. That gives me 5.4, and if I hit that, it tells me 27 over 5. Okay? All right, what is the 0 on this? Okay, you can just do this by graphing. Anytime they ask for a solution or a root or an x-intercept, you could just graph this. Okay, and that's going to be negative 4 or 1.7. Well, you don't see negative 4 up here, so one of these has to be 1.7. Well, let's look what 12 divided by 7 is. Well, that's 1.71, so that's the match. If you wanted to, you could always multiply that. That's 7 times negative 48. That's negative 336. And you'd have to find the factors in negative 336. Divided by 2, that's probably not going to work. 3, that's not going to give me 16. 4, no. 5, no. 6, still too big of a gap. 7, that and that, nope, not quite. 8, getting there. 9, 10, 11, 12. That's actually what it would be negative 12 and positive 28. So if you did the box, this is just another way to do the same problem. That'd be 7x, x, 4, x minus 12. And if you solved each of these, that's x equals negative 4. That's 7x equals 12 divided by 7. Okay, so 2 ways to get it. I think graphing it probably is easier. Okay, what function is the inverse? So remember, we make that a y, and then we switch x and y, and then we solve for y. All right, how would I get rid of the cube? Take the cube root. So that would be my answer. That's A. Okay, what is the domain? Well, you got to look at the asymptote. Okay, so our asymptote is x equals 1. So on our graph, a log looks like this. Okay, so if this asymptote is 1, that's 1, negative infinity. This is infinity, infinity. Okay, all right, the smallest x to biggest x. So that's greater than 1. Okay, all right, but you got to know the asymptote. Okay, radioactive decay, what is the closest to a sample exponentially over time? So what I got to do, I'm going to go back to that table. So I got that table. I got 0. I got 1. I got 2. I got 3. I got 4. That's 80, and then 56.6. 40.0. 28.3. 20. Y1, ABC, okay, A, B, parentheses, exponent, next to the first. Okay, all right, and all right, I got the equation. Now it says, what will it be at 5 minutes? So I got x equals 5, okay? So what I want to do is I want to put x equals 5 in here, okay, and find where it intersects. So it intersects right there at 14.1, and that would be my answer, okay? Only 2 more left. What is the sum of the first 20 terms? Okay, so this is actually an arithmetic, all right, and the sum is, formula is this, n over 2, 2a1 plus n minus 1 times d, okay? Now, they're telling me it's 20 terms. My first term is 1/3. It's 20 minus 1. The difference is I'm adding a third every time I go. Now that sometimes looks like geometric, but in this case it is not, okay? So I got 20 over 2 times, whoops, sorry, 20 over 2 okay, over here, close the parenthesis 2 times, okay, first term was 1/3, so 1 divided by 3, okay, hit over, close parentheses, plus, parentheses, 20 minus 1, okay, close it, and then the rate was also 1/3, so 1 divided by 3, click over, close it again, so it gives me 70. Okay, and then the last question, okay, permutations, how many possible permutations? All right, so what you can do is if you go to functions, okay, and keep scrolling, okay, eventually, functions, okay, you get these NPR, okay, which, let's do 8, choose 3. So 8 comma 3 tells you 336. So if it's permutation, you pick that. If it's combination, you pick the other one. So that's the video, all right, for the first practice.